Awesome. Okay, so we got Zoom fixed. It's projecting the screen. So we're working on tangent lines right here. For those at home, we're trying to find the equation of the tangent line to the curve f of x equals 1 over x minus 3, and we want to do it at the point 5 1/2. Maybe I'll write that a little bit bigger. 5 1/2 is where we're going. So 5 is going to be our x naught. And that is our f of x naught, because that's the point that we are approaching. So that's the equation for f of x naught plus h. All I've done is substituted, instead of having x, I had x plus h. Well, x naught plus h. In our f of x, which plugs it in over there. X naught was 5 though, so we plug that in and we've got 1 over h plus 2 minus 1/2. I move the h on bottom over to the front as 1 over h over here. We got a common denominator. And so far we're cleaned up to this point right here. The h is canceled. And I'm left with the limit. As h approaches 0, I clearly need to give more space on this page for my writing when I make this paper. I've got negative 1 over 2 times h plus 2. And now if I plug in h equals 0, I don't have a problem. H equals 0, this leads to negative 1 over 4. That's the slope of the tangent line. This is m tangent. Negative 1/4. That's a pain in the ass. We don't even have our tangent line yet. We still got to do y minus f of x naught. So y minus 1/2 equals m tangent, which is negative 1 over 4. And then we've got x minus x naught, which is x minus 5. That is the equation for the tangent line. We probably wouldn't leave it in that format. You know, solve for y. But that's some algebra shit that you guys will do on the homework. You get practice in later. Yeah.
Just one more time, could you explain how we got f of x naught plus h equation? How we plug the values in to get that?
Right here? Or up here?
How you found that?
All right, so. Grab another piece of paper. We have f of x equals 1 over x minus 3. This x is this x. So if I take x naught plus h and I plug it in there, I have to replace it for every x in the actual function. Is that the question? Because then we had x naught was 5. So this was actually 5 plus h that I was plugging in.
Okay. You also wrote that f of x naught was equal to 1/2.
That's f of x naught.
That's not okay, so it's different from f of x naught plus h. That's the difference.
Correct.
Oh. Okay. I get it.
Yeah, f of x naught, we actually know the value.
Right.
And it's listed here. And we still could have used it right here. X naught is 5. This is f of x naught is really doing f of 5. And we're doing 1 over x minus 3. So 1 over 5 minus 3 gets us that 1/2. So like you could have seen it from the point here. That's an f of x naught. My graph is going to shit back there. Or you could have plugged the x naught in and just found out what it was. In both cases, you get that 1/2. Any other questions? Oh, do you guys want to do this at another point on the same fucking line?
Yeah.
This would get tedious doing this repetitively. Right? What if we wanted like 10 points? There's a better way. Let's look at doing a better way, and then we can evaluate at any point. Let's do a generic X naught. We'll just use a generic X naught. And then when we get it all solved, we get this formula and we can just plug it in. We're going to do that on this next problem right here. And since I crossed the shit out, I will just say what it says. On the next problem, we have find a formula. For the line tangent to the curve. F of x equals x squared minus 3x plus 1. At a general point, x equals an x naught. This is the better way. And then we're going to use it to find the equation at 1, -1. Another perk to the Tulare campus, less classrooms, so less rooms that need tech help, and they get over here right away. They're not busy. I like the Tulare campus. All right, so limit as h approaches 0 of, we're doing f of x naught plus h minus f of x over h. So what does this mean for us? Limit as h approaches 0. I'm going to move that h on the bottom out front real quick as 1 over h. F of x naught plus h means plugging in x naught plus h everywhere into f of x. So I have the f of x function is I've got x squared minus 3 times x plus 1. And I'm not going to use x, I'm using x naught plus h. And then we have minus f of x naught. So we have minus x naught squared minus 3x naught plus 1. And we're going to end that parentheses. Everyone okay with the substitution so far? All right, so we need to do stuff with that. Gotta clean it up. This x naught plus h squared. Recall that is x naught plus h times x naught plus h. And that does not equal x naught squared plus h squared. You actually have to multiply it out. If you multiply it out, you have x naught squared plus 2x0 h plus h squared for that one. Wait, don't need a parentheses right there. Then I have minus 3x0 minus 3h plus 1. That's the first part. That's my first function. And then our f of x naught, I'm going to distribute the minus, and it's just going to change the sign of what's inside. All right, so what cancels out here? I've got an x naught squared and a negative x naught squared. Those are going to go away. I have a minus 3x naught and a plus 3x naught. And I've got a plus 1 and a minus 1. So when we clean that all up, we have 2x0 h plus h squared minus 3h. For polynomials, if you've done this correctly, you'll notice these all went away. F of x naught was entirely canceled. Was countered, I should say. Polynomials is always going to work. When we look at trig functions and stuff, it's a little different. You guys don't know how to do the polynomial version of trig functions yet. But notice I can factor out an h here. I have an h, and that leaves behind 2x naught plus h minus 3. And so the 1 over h and h cancel. We're left with the limit as h approaches 0 of 2x naught plus h minus 3. And we're going to see that equals 2x naught minus 3. And this is the slope of the tangent line at x naught. Any x naught. So we've got this graph x squared minus 3x plus 1. X squared minus 3x plus 1 is going to be a polynomial or a parabola going up somewhere. And this allows us to find the tangent line at any point on the curve just by using the formula. So rather than going through that long drawn process we did with the first one, we did a little bit more work because we had to use a general form and shit didn't cancel as easily. But once we've got it, now we can find the slope anywhere. Finding the slope at 1, negative 1. So at 1, negative 1, m tangent equals 2 times 1 minus 3, which happens to equal negative 1. which is a coincidence that that's the same value as f of x naught right here. And our tangent line becomes, we have y minus -1 equals m, which is -1 times x minus x naught. Y minus y naught equals m times x minus x naught. We clean this up, we've got y plus 1 equals -x plus 1. And all we get at that point is y equals -x. At x equals 1. That's the tangent line. If we look at the same, find the tangent line at x equals 0. What about x equals 0? Well, this is still, we're still doing f of x equals x squared minus 3x plus 1. So f of 0, which will be our y value, is going to be 1. And now we're going to do our m tangent is 2x naught minus 3, which is 2 times 0 minus 3, which is -3. And so at x equals 0, we've got y equals 1. We're looking at the point 0, 1 with this slope right here. And our tangent line is y minus 1 equals -3 times x minus 0. There's a faster way of doing this, of course. You'll see that we get y equals -3x plus 1. Which we could have jumped straight to using the slope-intercept method. That's m, this is b, y equals mx plus b. This only works when x equals 0. So different tangent lines for different points on that graph. I'm so glad you got Zoom fixed. I like that cup, Sensi. Is that a fucking mason jar with a lid and a straw? Guy, mason jars are the best. Drinking out of a mason jar feels so hillbilly, but it's fucking awesome. They like make nice little drinking vessels. And she made it spill-proof for a computer class. Excellent. All right. So you guys ready for more? All right, so we've got velocity. Velocity is speed with direction. That's the short way of saying, or the long way, or short way of giving you the definition of velocity. It's going a specific speed in a specific direction. So, and And how do we come up with that? We have an object, it's moving along this, let's say it's going in a straight direction. It's moving along the coordinate line, and so we give it its position as S. S is going to equal f of t. So, and it doesn't necessarily have to be a straight line, but I'm going to do a straight line. So we're going to have t along this axis and s along, nope. Yeah, s along this axis. And I've got some line here. And at this time, it's time t. And when we go a distance over delta t, this is t plus delta t. So the change in S value, this is f of t right here. This is f of t plus t delta t, t plus delta t. That's an f right there. And so if we want to find this difference here, this delta S, delta S is going to be, as it shows up here, f of t plus delta t minus f of t. Or just subtracts how you find distance. You subtract one length from the other. And that's called displacement. Delta S is displacement. It's spelled right there. And speed is distance over time. So is velocity. Velocity is the distance over time. So the average velocity, we go by v. The average velocity is going to be the change in displacement or position over the change in time. And that gives us f of t plus delta t minus f of t. That's the top. When we do t plus delta t minus t, we just get delta t on bottom. Okay, so if you're going upwards, if delta S is going upwards, velocity is increasing, or velocity is positive. And if delta S is downward, like if the line is going downward, velocity is going to show as negative. Speed is always positive. So we say speed is the absolute value of velocity. It also kind of gets rid of direction. So that's the average velocity. If we're doing t plus delta t. Now, as soon as we switch from t being somewhere distant than delta t plus delta t, as this t plus delta t goes to 0, this point comes down, down, down until all of a sudden there's only 1 point. Now, all of a sudden, we've only got 1 point, and this is delta t goes to 0. This is like instantaneous velocity. Not like an average velocity, but like if you took a snapshot of a car going, it would be the exact speed at the exact time. And that's going to be the limit of f of t plus delta t minus f of t over delta t. We use t for when we're talking about a lot of things in physics, because a lot of things change with time. This is no different than doing f of x plus h minus f of x over h. You guys see the connection with that? This looks a lot like f of x plus h minus f of x over h when we do limit as h goes to 0. So it's the same shit going on. We say velocity is the derivative of position with respect to time. We always got to say with respect to what? It might be with respect to distance, it might be with respect to position, it might be with respect to time. There's always some thing. In fact, when we talk about derivatives, we say with respect to so often, we say this part so often, we abbreviate it W dot R dot T dot. If you say W dot R dot T dot to anyone that's taking calculus, it means with respect to. All things motion related are derivatives of other things. The velocity is a derivative of position with respect to time. So velocity is a change in position over a change in time. Acceleration is a change in velocity over a change in time. So acceleration is the derivative of velocity. With respect to time. That also makes this. This is the second derivative of position. With respect to time. What is? Well, let's chalk it. Before I tell you what it's called. If we have a change in acceleration, we use A for acceleration. A change in acceleration with respect to time. A change in acceleration is like when you slam on the fucking brakes because some asshat fucking like runs a red light right in front of you and you're gonna fucking slam into him. What happens to your body when you fucking slam those brakes on? You fucking damn near get whiplash, right? Inertia happens. Your body wants to keep moving, but the car isn't. And your body isn't because you presumably, hopefully have a seatbelt on. So your neck fucking jerks forward. This is called the jerk. Jerk is a change in acceleration over time. So jerk is the derivative of acceleration. With respect to time. And that makes it, this is the derivative of the second derivative, which makes this the third derivative with respect to position. Or third derivative of position. I'm off screen. That's some physics for you. This is pretty neat because there's a couple classes here that teach physics. One is like physics 20 or some shit like that. It teaches you all the equations for motion using just algebra. But once you switch over to physics, what is it, 55 or whatever it is, the calculus-based physics, you start looking at how they're like the real way to calculate physics using derivatives. A lot of shit changes. A lot of things in physics are changes of something with respect to something else. So let's take a look at an example. I'm going to write the problem on this page. We'll do it on the next. A rock is thrown vertically upward. This vertically upward is important. When you start throwing it at an angle, velocity is affected partially by gravity, but when it's straight upwards, it's fully affected by gravity. A rock is thrown vertically upward from the surface of the moon. Well, that's an interesting touch. At a velocity of, we'll say an initial velocity of 24 meters per second. Units matter with velocity or gravity. Gravity has a different value in meters per second than it does in feet per second. Okay. Actually, gravity is a form of acceleration, so it's meters per second and feet per second, or a meter squared and feet squared. Where am I going? It reaches a height of, and since the height is dependent on time, how high up the rock is how much time since you've thrown it. It's gonna be 24t minus 0.8 t squared. Where t is in seconds. Find the rock's instantaneous velocity at t equals 2. Thank you. As a reminder, I will be in the Mesa room, JM 124, on Saturday from 9 to 12. And tomorrow they have that breast cancer presentation. The research on breast cancer, I should say. So if you're interested in that, it's at 1 to 2. In I think 107 over there. And then I'll be in the Mesa lab from 2 to 3. Before I torment Ainsley again in Seaside 2. This is what happens. You take 2 classes with me, you're the only student that does, your same name gets said a lot. This is too bad for Ainsley because she's really fucking quiet. She probably doesn't like the attention. All right, so how do we do this? This delta S over delta T, we're looking for the velocity. And we want the instantaneous one. This has got to do the limit as delta T goes to 0. And we're doing f of t plus delta T minus f of t over delta T. So we have our f of t, that's given. 24t squared, or 24t minus 0.8 t squared. That's f of t. F of t plus delta t, let's just work it out over here before we put it all into the equation. We have to do 24 and then t plus delta t minus 0.8 times, normally it's t squared, but now it's t plus delta t squared. And we've got some cleaning up to do here. This is 24t plus 24 delta t. And I have minus 0.8. This is t squared plus 2t delta t plus delta t squared. How about we just call delta t h? That way it doesn't look like this t, it's less confusing. I'm going to call this h. But h is really a change in t. So if I clean that up more, let's see what we got. I've got 24t plus 24h minus 0.8 t squared minus 1.6 th minus 0.8 h squared. That's my f of t plus delta t, or t plus h. We still got to put it all together. Is everyone kind of like with me? Is everyone getting a little bit more comfortable plugging in, making these substitutions into f? It's getting a little bit, makes a little bit more sense each time you do it. Yeah, new experiences are always feel weird at first, and pretty soon it becomes second nature. Maybe not pretty soon, but eventually. So now we need to put this all together. I need to do the limit as h goes to 0. And we're going to have our f of t plus h. We have a 1 over h. I think that is a much easier way of doing it, rather than putting h in the denominator. It makes it easier to write without having this giant fucking fraction all over your paper. That's awkward. I've got 24t plus 24h minus 0.8 t squared minus 1.6 th minus 0.8 h squared. That's my f of t plus h. Then we have minus f of t is going to be minus 24t and then plus 0.8 t squared. That's a lot of writing, right? Thankfully, this shit gets faster in 2.2. But you need to know where the fundamentals come from, why it works. Otherwise, it just looks like magic, like I'm making shit up. This is why calculus was developed, to mathematically interpret rates of change. And most likely it started with velocity relating to position. That's got to be one of the first things we studied when we're fucking studying rocket science, right? That came later. All right, so a little bit of a clusterfuck going on. But shit cleans up, right? If this holds true, what I said earlier holds true, these should cancel out somewhere over here. And these should cancel. And so minus 24t, look, I've got a positive 24t here. And I've got the negative 0.8 t squared there. So we have the limit as h goes to 0. We've got 1 over h. And we're left with 24h minus 1.6 th minus 0.8 h squared. I was factoring in out of h earlier and canceling. Alternatively, you can multiply or distribute the 1 over h in. And we get limit as h goes to 0 of 24 minus 1.6 t minus 0.8 h. So we evaluate that. H goes to 0, we just get 24 minus 1.6 t. This is the velocity at a time t. For this problem. If it's a rock isn't going straight up, like if you're throwing a baseball to someone else, you've got an angle that you're throwing it out, some trig shit falls into this, and you're not ready to see trig and these derivative things yet. We'll get there though. So at t equals 2 seconds, what do we got? Because they asked, this isn't the final answer. It said, find the rock's instantaneous velocity at t equals 2. At t equals 2, I have 24 minus 1.6. What? Times 2. This is 24 minus 3.2, which is 20.8. What are the units here? Meters per second. Delta S was, we even had the initial velocity was in meters per second, so they kind of gave it away. So that's our velocity t equals 2. We didn't do acceleration. Acceleration, though, the units on acceleration is meters per second squared. And let's take a 5-minute break. Let people go to the bathroom. Stretch. Text your bow. Let me hit pause. So velocity is just one form of rate of change. It's one that everybody has experienced because you all moved. You've always, not always, but everyone has been in motion at some point because you got to class. But rates of change can occur in a lot of ways. One example is like a microbiologist. They might be interested at the rate of change in which the number of bacteria in a colony change with respect to time. They might call that delta B over delta T. Generally, we use lowercase letters, so maybe lower b. An engineer might be interested in the rate at which the length of a metal rod changes. Sometimes we use L for length, sometimes X. So this metal rod changing with respect to temperature, temperature is always a capital T. Off the screen, thank you. An economist might be interested in the rate at which production cost changes. So when cost changes, we tend to use delta C or cost. And it might be related to how many, well, definitely related to how many you produce, how many units per you produce. Oftentimes we'll just use X for units. So if you look, we do two things. We do the average rate of change and the instantaneous rate of change. The average rate of change is when we have 2 points, kind of like on the velocity function, we had t that at time t and at time t plus delta t. When we do it here, we're going from x naught to x1. So we say f of x1 minus f of x naught over x1 minus x naught. It's still a slope. This is still a y1 minus y0 over x1 minus x0. That right there. The only difference that changes when we go to the other one is we are calling this h. And so if h equals x1 minus x naught, and I want to just use, I want to clear this up and I want to address this f of x1, I can add x naught to both sides. And I see that x1 equals x naught plus h, which is why x1 changes to x naught plus h. That's where that change is coming from. And when we do the instantaneous rate of change, we do the limit as one point approaches the other. As x1 goes to x naught or h goes to 0. So like speaking generally, when we're doing a rate of change, we'll have the units, how much the units of y are changing with respect to how much the units in x are changing. And this is done by division. So the change in y over the change in x. That triangle, the delta symbol, stands for change in mathematics. I don't know if I've said that in this class on a given day, but delta means changing. How is it changing? And like it says, we still want to simplify according to our regular old algebra principles. We're going to look at an example. We're not going to walk through it. We're not going to do the math. Just going to talk about what this change in means. So our example, is everyone ready to do the example? Or is anyone still writing above the example? If you're still writing above the example, please keep going. You don't need to rush it. Okay. No one said they're waiting or still going. So we're going to look at the cost of producing X ounces of gold from a new gold mine, and it's given as C is equal to F of X dollars. So this is telling us that C is measured in dollars. That's handy. Could have been a different country. Could have been the euro. Shit like that. So what are the units for the rate of change of C with respect to X? So translating A into symbols, the rate of change of C with respect to X, the change of C is going to be delta C. With respect to X, we're going to have delta X. C, we said, was dollars units. So we're doing delta dollars if we're just looking at the units. And X measured ounces of gold. So generally when we write it as a number, This is gonna be number of dollars per 1 ounce of gold. We try to write it as a unit cost rate. And cost of producing shit tends to go down for the more you produce. The reason why is the shit that you pay for that's a fixed value. Like, let's say you're working in a factory. The rent is a fixed cost, whether you make 1 item or 1 million items. So you can break up the cost of rent and shit over all the items rather than just 1 item. And so it tends to get cheaper. Cost tends to go down with the more you produce. Then it says, what does F apostrophe 800 equals 17 mean? Now, I haven't told you what F apostrophe is yet, but that's where we're going in just a second. F apostrophe, notice that we keep saying F of X naught plus H. This has shown up several times. This is very fucking tedious to write. That takes a long time to write every time off screen, right? Thank you. Just blurt it out. Just say off screen. If I don't glance up, I don't see your hand, but I will always hear you. You got lucky. Good. I look up a lot though. That's tedious to write, so we tend to write this as F apostrophe X. And the way we pronounce it is F prime of X. So the apostrophe symbol means prime. So when we say F prime of 800, what we're saying is, what's the rate of change at X equals 800? That's what F of 800, F prime of 800 means. So this means at 800 units, how the production costs change is $17 for the next ounce. Because we had 17 here. So it's like the cost to produce 1 more. It's the cost to produce 1 more ounce. Are we having fun yet? Yes, Mr. Jones, this is fucking exhilarating. This is better than smoking meth. I hope that's not your answer. Now, I'm not criticizing if you've done meth in the past. I did meth when I was a teenager. That was my drug of choice. But it's not productive to do it while you're going to school. So hopefully when you decide to go to school, you're not doing it here. Or you're not coming in fucking high as a kite on meth. It's not good for your body, and it's against the law. That's right. Even meth heads can become college professors. That ain't no joke. I am not joking. I did it for a long time. Everyone ready to go on to 2.2? Wait, I saw camera go. Anyone need that longer for a pick? Did you want me to? All right, 2.2, the derivative function. Woo! All aboard, let's do it. The derivative function, f of x with respect to x, is this function f prime, whose value at f prime of x is that function I just told you about. Limit as h goes to 0 of f of x plus h minus f of x over h. There's a very important caveat there. Provided the limit exists. This is huge. We can't have the derivative if the limit doesn't exist. Now, I don't know why I have alternate form here. I think I originally had f of x 1 minus f of x 2. I just wrote it bigger there. So we're just going to look at some examples and we're going to grind out what we've been doing in the last hour. If f of x equals x squared plus 2x, find f prime of x. So I need to do this f of x plus h. X plus h squared plus 2 times x plus h. That's matching up with my x squared plus 2x. Just with x plus h substituted in. Then we have minus f of x, which is minus x squared plus 2x. Now I need a limit here. Limit as h goes to 0. And I need to put this all over h. Everyone go with that input right there? Y'all keep taking pictures. You know I fucking upload this shit to Canvas, right?
It's easier like to see.
Is it?
Yeah.
All right. That's cool. I guess it's easy to zoom in and shit like that, but
It's
I don't know.
It's just like you strike pictures with like your pen and stuff. So like I get a little confused. Like take a picture, like take a closer look. Oh, okay. Makes it sound.
all right, so we got to figure out what that shit is. I got limit as h goes to 0. I'm going to move that over h to the front as 1 over h. X plus h squared. Remember, this is, you got to write it out. A lot of people, I've seen Calculus 3 students fuck this up repeatedly. Remember, it doesn't mean square the things individually. You got to multiply that out. That is x squared plus 2xh plus h squared. Then I have 2 times x and 2 times h. And I have minus x squared and minus 2x. All right, so some stuff cleans up, right? For polynomials, this should cancel. Let's go find it. I've got an x squared here and a 2x here. I am left with 2xh plus h squared plus 2h. And when we distribute that h, or 1 over h, we have a limit as h goes to 0 of 2x plus h plus 2. And now we can stick in h equaling 0, no problem. And I get 2x plus 2 is f prime of x. There is a faster method to do this. I said 2.2. I fucking lied. It's 2.3. You got to struggle with the limits for a little while. Get used to them. They're only really going to show up on the first test, maybe a problem on the final. But this limit shit, you got to know how to do it because it's really what's going on with everything. All right. Are you guys ready? I see some pins still going. I'm going to start writing the next problem right here because I think it's going to take a full page to write with this giant fucking marker. Find f prime if f of x equals 2 minus x over x plus 1. Fuck. Fractions are never a good thing. Right? Don't you all kind of like die a little inside when you see a problem with a bunch of fractions? You're going to get good at your algebra and your fucking fraction shit in this class. If you weren't good at it, if you got like a B or a C in algebra, guess what? Your game's going to get fucking elevated or you ain't going to make it. You're going to get good. How do they spell it? Get good, like that? Fucking gamer slang. Right? Get good. Like you fucking keep dying, quit crying to me about it, get good. All right, let's take a look at it. I assume everyone's got it written. Fuck are you writing, Sensi? You're not even looking up here anymore. All right. So let's do this god-awful problem. What do we got going on here? I need to go through, remember we got, maybe this might be easier to write the f of x plus h separately. Let's take a look at what's going on there. I need to plug in x plus h everywhere I see x. So this is going to look like 2 minus x plus h over x plus h plus 1, like that. Now, I recommend when you're substituting it in, always use parentheses whether you need it or not. Like on the bottom, the parentheses aren't doing a lot, but if you get in the habit of doing it, you won't fucking fuck it up later on. Because the top, that negative, it has to hit both of them. This is 2 minus x minus h, and the bottom is x plus h plus 1. That's not so bad yet. It's when we hit the limit. We're doing limit as h goes to 0. We're doing, I'm gonna have a 1 over h. I think it's easier to write it that way. We're gonna have that 2 minus x minus h, or f of x plus h, over x plus h plus 1. And we're subtracting f of x, which is 2 minus x over x plus 1. And you'll see I left some room in there because we don't have the same denominator. So what do we gotta do? Yeah, multiply by the other denominator. After you have to do this by hand for a little while, you're gonna really appreciate the derivative rules that we're covering soon. Okay, so I've got the limit. I'm gonna not factor out the bottom. Leave the bottom alone. But we do need to multiply out the top. So this is just a slow grind. I'm going to distribute the 2. I've got 2x plus 2. I've got negative x squared minus x. And I've got negative hx minus h. Ainsley's smiling. She likes this. Don't shake your head now. No, you do. You're like, this is fun. It's like solving a little puzzle. Who doesn't like getting a puzzle right? Then, ooh, this minus thing here. Should we try to deliver the minus right away? I'm going to say no. Let's deliver the minus that's between them afterwards. Or check this out. Or we could do it now. That minus 2 minus x right there on top. I can distribute that and that becomes negative 2 plus x. Or I could treat it as x minus 2. So I could distribute the negative and make this x minus 2. And not have to worry about the negative later. How does that sound? Do you guys see that transition there? If you don't see what I did, please say something. I moved the negative inside the 2 minus x, and it changed the sign of everything. So the 2 becomes negative, the x becomes positive, and I just changed the order so it's got a nice pretty order. So I am going to now distribute that x minus 2. I'm going to put that back to a positive. I've got x minus 2 times that. So I'll distribute the x to everything first. I've got x squared plus xh plus x. And then I've got minus 2x minus 2h minus 2. And I don't need the parentheses anymore. But rather than scribble them out, we can clutter it up. I'm just going to leave it. I should end my bracket though. Bottom isn't changing yet. What's going on top? Let's start looking for shit that cancels. Rather than cross them off, I'm gonna circle them. How about that? Let me pause a minute and make sure everyone's got this written before I start circling shit, making it hard to read though. Yeah, Matthew.
We put 1/h out front, what did that do again? Is that?
The 1/h is doing the. Addressing this h on bottom right here. I'm just moving it in front so that I don't have a giant fucking fraction. I have it here now because I have a big fraction and there's no avoiding the fraction. So I put it back underneath. The reason why I was doing it up here is because this would all technically be over another h.
Oh, yeah.
You know what I mean?
Okay, yeah.
So we got fractions in fractions.
That's because I saw that h from x.
Yeah,
And I was like, oh, wasn't that supposed to get rid of that h? But
not yet.
different h.
We gotta clean this. It's all the same age. We just, yeah, but yeah, I hear what you're saying. I know what you mean. All right, so let's start circling shit, see what goes away. I see, do I have a 2x anywhere? The easiest way to do this is go left to right. I've got a 2x here. I've got a negative 2x over there. Those are gonna cancel. I've got a +2 here and I see a -2 over there. Those are gonna cancel. I have a -x² here. I have a +x² here. Those will cancel. I have a -x here and a +x here. Those will cancel. I have a -hx here and a +xh here. Those will cancel. Holy shit. This really cleaned up a lot, right? All we've got left is that bad boy and that bad boy. And they don't cancel, they just get added together. That makes -3h. All that shit cleaned up to go almost completely away. So when we keep going with this, the limit as h goes to 0, the h on top and the h on bottom cancel, right? And I don't have a problem sticking in h equals 0 anymore. If I plug in h equals 0, I've got -3 over x plus 1 over x plus 1. So this is -3 over x plus 1 squared. That actually ended up not looking too bad at the end. All right, our lecture notes have 2 more examples and a rule set and a theorem. So I think I'll do the examples later and I'll just talk about the rule and the theorem here. What's up, guys? Joseph. He was a troublemaker last semester. He turned out to be a good student at the end. He fell for the Hefe charm. All right. So I'm going to do that example on a video. Let's take a look at this differentiability rules here. So we say a function f is said to be differentiable at x naught if the limit exists for that equation, for our equation for f prime of x. And f is differentiable at each point on the open interval a to b. So like not just a point, but a range of points, like a whole line segment. If it's differentiable at each point, we just say it's differentiable on the whole thing, which makes sense. We don't go through and say differentiable at each point. That would get tedious. But there are some functions that don't have derivatives. Things with a corner are an example. I'm not really sure what the difference between a corner and a cusp is. Cusp tends to be more like, I don't know, that, but that looks more like a corner to me. Maybe that's the corner and that's the cusp. I don't know. A vertical tangent. A vertical tangent occurs when f of x does some, let's see. And you can get the tangent line, vertical tangent line, like right there. And it actually goes through it rather than, there's some problems that have this. The discontinuity thing is pretty important because this means it's not differentiable where it's not continuous. That's pretty huge. This makes that whole continuous or continuity idea very, very important for all of calculus. Wild oscillation is kind of like something like the function does some shit like that. That's a wild oscillation. And what makes it too wild to have a derivative? You kind of just have to try to find the derivative and find out. You'll quickly identify these things where the names won't matter to you. You'll recognize where there's a problem for many of these right away. With experience, with time. Your final theorem. You don't need the proof so much. If you want to see the proof later on, you can always go look at the lecture notes. The important thing is if f has a derivative at a point x equals c, then f is continuous at x equals c. This kind of goes along with the red writing I have right here. It can't be differentiable, or differentiable means it has a derivative. Can't be differentiable if it's not continuous. This theorem is saying the same thing. And if you want to take a picture of the proof right now, you can. What I will point out right here, because this one, everything is kind of like you can follow what's going on, except this first step right here is a little hard to read. We start with this. And then I add f of c minus f of c. That's what I did. So here's my f of c. There's my minus f of c. Because that equals 0 and I haven't added anything, right? Nothing's been added, nothing's changed. And then I group them up and I do the f of c plus h minus f of c. I do this times, this is doing times h over h, which is 1. So I'm not changing anything there. But now I'm set up with a nice little limit property. I can do the limit of this part, I can do the limit of this part, and the limit of this part. I will do the two examples, example 3 and example 4, in a video today, just so you can see if you start on the homework early. Example 3 is working with the square root of x. What the fuck happened? Example 3 is working with the square root of x. Example 4 is working with the absolute value of x. So like weird functions. I will see you guys on Tuesday. It's a 3-day weekend. I hope you guys are able to make it to Macy tomorrow or on like for the presentation or on Saturday. I'm there. Have a good weekend.